Is it possible? Did we make it through a whole episode without controversy? Yeah!
This week's episode of BattleBots was one of the best episodes of the season. If you haven't seen it, you're missing out. And you're about to get all sorts of spoilers from our show.
This week we talked to Valkyrie's Leanne Cushing after their second win. We talked to Alex Hattori about Uppercut's victorious win over Sawblaze. And we also talked to Joe Fabiani, and he tells us all about Longboy SMEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeee
I'm Will Bales from Hypershock.
We're Mike and Andrea Galately from Team Witch Doctor.
And this is the Tale of the Tape After Show. Welcome to the Tale of the Tape After Show. Let's get started with our 30-second recap.
30 seconds on the clock!
RotatoR and Valkyrie put on a fireworks display. Gigabyte spins Extinguisher's axe head round baby right round. Slapbox suplexes a giant shark. Malice does the thing and gets stuck on its back.
Tantrum punches its way to glory. Pain Train versus SMEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEEeee happened. And the judges need a Uppercut blows up Sawblaze right in their face.
In this week's first deep dive, we're going to talk about Valkyrie and RotatoR. And that was a heck of a match. Both robots worked the entire time. Big, giant hits were dealt. What did you guys think?
I mean, I thought it was incredible. I mean, that is the kind of fight that BattleBots wants. That's the kind of fight the fans want. So if you're trying to build a robot for BattleBots, do that. Like, do that. Exactly that.
Speaking of which, let's talk to Leanne so she can tell us exactly how she did that.
So the biggest changes to Valkyrie this year, I think probably, like overall, I think like top-down system is kind of the same. We have a lot of like engine nerdy, nitpicky changes. Like we updated our drive system. We actually have new wheels. We did a bunch of testing, figured out like what has more oomph. Like I know early on when I first moved out to California, I was getting video from Fred just like driving things into walls and seeing where the burnout happened. That was useful. I remember actually mid-season last year, we did make a drivetrain like sticky upgrade for our friction, which was copying Ribot and having like a urethane coating on the outside of the wheels that made it so we sounded like a basketball team in the test box. And like we could control everything. It was less of a hover sway and more of just like a move with intention. And so I think like that obviously helps a lot. I'm actually still a little bit worried about how much shoving we can still do, especially versus our fight versus Tantrum, but we'll see. Valkyrie had a huge makeover, thanks to my teammate Alex. We look like a spaceship. It's super cool. I love the way a robot works. I like our robot looks so much better than the last two seasons. Now without the greebles, I feel like it's naked. So that's how you always know like a design choice was purposeful or like had a point of like, if you put this thing on, does it look stupid or not? But then when you take it off, if it's not the identity it first was, then like spaceship Valkyrie, best Valkyrie. The weapon motor this year we've been using the last couple of years are lost from last year, Quantum. The Cooper brothers actually helped us out with understanding our Lynch motor more. We were able to learn how it likes to behave, how to better secure it, rather than just the off-the-shelf mounting options. We made our own encasing for it, and I think that helped a lot. It did add a little bit of weight, but thanks to our designed frame rails from Autodesk Fusion 360, one of our sponsors, we were able to actually go ahead and dial down the weight of our robot by a couple pounds because we shaved off like 0.2 or 0.3 pounds per rail, and there's 8 of them. So Valkyrie is tricky in that when we first started designing it, we did keep in mind that we'd have a very powerful, heavy moment at the center where the weapon was for how it would drive. Without a weapon on it, it drives like a jet ski or hoverboard or something stupid. With the weapon on, without it moving, it's more level because of just like the slight tilt that we made it for the undercutter. With the weapon off, safe. I actually posted a video of Fred riding on top of like a robot flipped upside down as like the most expensive sit and scoot ever. But like besides joking around, like we don't usually drive it with the weapon on outside of being in the test box. We try to theoretically on an engineering side make sure that it drives as solid, as balanced as possible when we're in the box, because otherwise, like, that's an advantage for someone else if they get under us in some direction. And I personally think there's a couple of directions that can currently happening, and I'm trying to figure out something else. We have a ton of different weapon choices. They do keep growing by the year because we like to recycle. We had our Dr. Teeth from last year. The teeth kind of got to nubs. So that and Sweet Caroline, which we also ran a bunch. Not me, not we. My teammate Amanda is a brilliant welder, fabricator. She actually used her knowledge of metals to make the edges of those dulled down blades stronger. So we brought them back as Mr. Cavity and Sour Caroline this year. Sour Caroline is actually a sharpened edge of our bar spinner. And then Mr. Cavity is just a hard face. We'll see if it works, which is us working on figuring out a way to like play with that temperature zone at the very end teeth, but not the full form. So you can keep the strength of a full body without like weakening it anywhere. And in theory, it won't shear off. We actually had a new custom controller this year that Fred and one of his friends at MIT built up. We ran that with Tantrum. We ran it again later. It doesn't work out as well as we were hoping for overall, but we were able to learn that last year our like 6 fights we had was a very hard stress tester for the weapon controller we're currently using, and so that's actually what we folded in during our RotatoR fight. It's tried and true. It does not stop, except when the thermals decide to auto power off, which is what happened at the end of that fight. So whoops. We're actually working on 2 different options now to make sure that will never happen again.
Our next deep dive is with Joe Fabiani with the longest robot in the whole competition.
And also has the longest name, too.
Fabiani's not that long. Neither is Joe, for that matter.
But how many E's in SMEE is still up for debate.
Yeah, well, we can ask Joe right now with SMEE.
SMEE was a bit of a joke originally. I brought it to a competition called Motorama in the 3-pound weight class. I built it in like 2 days just to make something fun because I didn't like my other robots at the time. And I sort of left it on the table there overnight. And so I went back to the hotel and I woke up in the morning, everyone was texting, it was all over Facebook, and people were really into it. So I was like, whoa, that is not what I expected. And then what I didn't expect even more was that the next day at the competition, it actually did really well. It won a bunch of fights, and it kind of captured everyone's heart. So I was like, okay, time to make a heavyweight of this. So I did. This is like what a SMEE wedge is in the 3-pound class. I'm using a titanium one now, but it used to be plastic just like the heavyweight. Here is the wedge for the heavyweight version. Or part of it anyway. This is definitely, I think, the thickest armor ever put on a BattleBot. Not in terms of strength, but just in terms of thickness. It's like 7 inches at the thickest point. 75 pounds-ish of wedge, which is kind of crazy, considering it's all CNC machined. Meaning this was all a giant chunk of plastic, and they ground it down to make it this nice shape, have all the holes, and most importantly for the show, the hinges. This is how it actually articulates right here. there's going to be a steel pin in there, and that's how it opens and closes. You can see what happens when other robots hit it. Even without a weapon, they'll just chunk right into it, because obviously these robots are huge, and if they have sharp pointy wedgelets, like you saw Sharkobrian probably make these 2 holes, I think, just by slamming with its nose. And yeah, so it definitely takes damage, and it gets harder and harder to put the vinyl back on each time, and then it gets all bumpy and bumpy. So I have to figure out another solution, if I make another one, how to make it pretty every fight. SMEE is powered by all brushless motors. So these are one of our drive motors. They're actually really tiny, probably pretty underpowered as far as BattleBots goes, but we built this thing on a small budget, not expecting it to be as fun as it was. So definitely going to use bigger motors in the future. These were provided by our awesome sponsor, FlipSky. And they just have a direct gear right here to our bigger gears on the wheels. Some of those wheels are 3D printed plastic, some are steel. So with these big skateboard motors, they're great because they don't really require any, they don't really require much reduction. So you don't need to have a big gearbox on there or anything. We just use these because, you just gear here, gear on the wheel, and that's all you need. It saves a lot of weight, and it's really, really efficient compared to having like multiple stages in a planetary gearbox, something like that. So SMEE is actually extremely difficult to drive. The small one is okay. It's a little bit twitchy, but the big one is actually hard because it always wants to fold in on itself. You try to accelerate too hard, it'll fold. You try to back up, and it does this kind of weird jiggly thing. And you try to turn, and there's a ton of rotational inertia involved in turning because all the weight is on the outsides, which is, it means that when you try to turn, it's basically trying to spin way more energy than it would be if it was a small, compact robot of the same weight. So whenever I hand the controls to someone else just to test in the test box or outside my apartment, they actually haven't really been able to get it to move very much, which makes me happy that I kind of got the hang of it. It started off rough the first couple of fights at BattleBots, but by the end of it, I was in sync with the robot. It feels less like driving a car or some kind of mechanical thing and more like trying to operate like some kind of a noodle or something. It's not really stiff. And it's basically all on one stick of the transmitter. So it's all me, just this one stick mixed together. So I'm basically kind of trying to kind of twist it around the opponent just by flicking the stick around, and sometimes it works, and sometimes I end up with my back facing them, which is terrible. And I think in terms of improving drivability, I think I need probably more torque. We went with sensorless motors instead of censored ones because we don't want sensors failing on us during fights. It's happened to so many other robots, and our drive was very reliable, even if it wasn't the strongest. So I'm happy that it survived. Generally, becoming faster would be really an improvement. So, how to spell SMEE? I would do what I do, which is just whatever feels right. On the robot, I put as many E's as I can fit. So, I think on the BattleBots robot, it's 19. On the Beetle weight, it's 18. Sometimes it's less. On the new Titanium wedge, I think it's less. So there was a time when I would just tell everyone a different number every time, and I would spawn arguments on Reddit, which was really, really fun. But now I think it's time to open it up to the masses, and they can decide whatever the context. Maybe they hate SMEE and they only want to give me 1 or 2 E's. BattleBots on their Twitter gave me 1 E. That's really, really sad. So depending on how much you like me, also, you want to add more E's, less E's, that's great. The funnest fact about the robot is for all of the SMEE lettering on the wedge and on the discs, I had to design the font myself in Fusion 360. I did this because it has to actually be balanced. So the cool thing about this font is with this number of E's and with this S, it's actually perfectly rotationally balanced around the center. So I didn't have to worry about offsetting the weapon or changing the weapon anyway, because the actual letters are balanced themselves, which was really, really annoying. But it's kind of cool because it adds character to the robot to have your own font. It doesn't look like anything you can just draw in Photoshop yourself. You have to actually, I had to actually design it in Fusion 360, both for the lettering on the wedge and on the weapons, which was hard and cool.
Our last deep dive is this week's main event between Uppercut and Sawblaze. I think this was a fight that surprised everybody, especially Alex from Uppercut. His facial expressions through this match are priceless.
Yeah, I mean, the hit, the explosion, just clipping Sawblaze and just obliterating Sawblaze like that. I mean, Jameson's an amazing driver. The robot's impossibly robust. So the fact that he basically one-hit KO'd Sawblaze is just insane.
Yeah, the show was talking about the explosion so much that they never really highlight the fact that Uppercut obliterated Sawblaze in a couple of hits.
So let's talk to Alex so he can tell us what's inside Uppercut.
Hey, I'm Alex, and I'm here to talk about this year's version of Uppercut. There were two main upgrades for Uppercut. The first was the addition of these new attachments that we call the horns, and the other was a total overhaul of our weapon motor system. Uppercut's a very pokey-looking robot, and there's a lot of different attachments sticking out at different angles, and those are all planned. They're all there so that Uppercut is unstable and its center of mass is away from its stability plane, so that it always lands and can flail with its wheels. And that gives us control in the fight. As long as our wheels touching the ground, we have some amount of control. You'll notice last year in the Bite Force fight, we didn't have anything that looked like these horns. And unfortunately, Uppercut lost because we face planted and could not move, and our wheels weren't touching the ground. The horns are stiff enough so that they won't bend under impact when Uppercut lands on them, and so they won't ever bend into the path of the blade like our previous horns. So one of the unique things that makes Uppercut seem so powerful on TV, it was one of our design goals. We designed it to be able to launch opponents into the ceiling, across the arena, or as we call it, yeeting, rather than grinding or taking little chunks out of the other robot. And so we do that by getting a lot of bite out of our opponent. So if you'll see, with Baby Uppercut, this is a replica of our fist. And so, just like you saw in the Science of Uppercut's Blade segment, this is a single-tooth weapon, so we have a lot more time to move into the opponent before the blade actually makes contact. And then the blade itself is also quite wide, so it doesn't actually have a lot of pressure and doesn't cut through the material. Instead, it can sort of catch its opponents, deliver as much energy into them as possible, and then with this angle, it can sort of launch them across the arena, like we've been seeing. So this is sort of a long story, but it starts off with my freshman year with the original Combat Robotics Club team, the Dentist. So, really astute BattleBots fans will know that there was a MIT Combat Robotics Club team called the Dentist that existed at the same time as Sawblaze in their first season. And so with the Dentist, they had these very ambitious goals. There was no tip speed limit at the time, so they wanted to spin their drum at 20,000 RPM. It was going to be powered with the inverter from a Toyota Prius, all these awesome motor science tests, really. But unfortunately, due to time constraints, the Dentist team wasn't able to get the robot finished in time, and so even though they were at filming, they didn't get any fights. But the same sort of technology has existed around MIT. Those same people, they developed their motor controllers, and so this year, we were finally able to use the real science that our teammates have been working on since my freshman year. And so, the big weapon overhaul was with a completely new weapon motor system and a custom controller. So, believe it or not, last year's version of Uppercut actually stored the same amount of energy as this year. The problem was that Uppercut wasn't able to deliver that energy effectively to its opponents due to a pretty silly problem. So we used off-the-shelf brushless motors and controllers because we assumed it'd be more reliable than making our own. But unfortunately, these controllers are not designed for combat, and so whenever we made contact with another opponent with our blade, our motor controller would think of that as a fault, and it would apply full negative torque and prevent the blade from delivering the full amount of energy that it stored, leaving Uppercut seeming a little anemic, especially compared to this year. So to fix this, we made an entirely custom weapon motor system. We designed our own motor, gearbox, and controller, all to go with Uppercut. And that's really the secret to how hard Uppercut can hit this year. So these motors are pretty interesting. We salvaged the motor parts from car parts from a junkyard in Cambridge, and then we designed these housings and gearboxes to go around them. And that's basically it. We built these modules without access to Uppercut due to COVID restrictions. So the first time we were ever able to see if these actually fit in the robot and worked was at the competition, about like a day before the Gemini fight. So that was pretty scary. But luckily things worked out. We did a lot of testing. We kind of designed everything to be as modular as possible so that we'd have the best chance of getting things to work. Frequently, Team Uppercut will be asked, how much torque can our weapon motors produce? And unfortunately, if we give people the answer in Newton meters, it doesn't really mean anything because most people don't have a good sense of what a Newton meter is. So recently we started to tell people that Uppercut has about enough torque to open 7 pickle jars in parallel with our new weapon motors. So if you can think about how much torque it takes to open a pickle jar, multiply that by about 7, and that's how much torque is going into Uppercut's blade. You'll see Uppercut intertwined with yo-yos quite often, and that's because Besides building robots, I'm also a competitive yo-yoer, and so I compete all around the world. And I also happen to be 7-time U.S. national champion. In my free time, I design my own yo-yos. My yo-yo sponsor produces them, and then I get to compete with my own designs. For this season, we decided to do something a little bit special, so they actually sponsored Uppercut by making us these Uppercut-themed yo-yos. On one side, you'll see the CAD model of Uppercut, and on the other, you'll see the Uppercut logo and our sponsor logo. So last year, BattleBots discovered that Zach Lytle from Scorpius and I had a little bit of history, and that actually started about 10 years ago at my first U.S. National Yo-Yo Contest. So after the contest, all the yo-yoers were in the parking lot of the hotel yo-yoing. And I remember Zach Lytle showing up with what I think is a prototype for his bot bash parties, and then he let the yo-yoers in the parking lot play with that. So that was honestly one of my first interactions with robots.
This week's Chris Roast of the Night actually comes from Kenny. Check it out.
Well, they got trapped in the corner in their first fight and got their shell knocked off. Gotta stay in the center tonight, Chris. It always works better when your head stays on. They gotta keep the head on. Huh. Details.
So about this, Gigabyte actually posted on social media a little while ago that about this failure mode that they had with their weapon shaft. Bam. So apparently, they credit us with it failing. There was some stress cracks from our fight last season, and Copperhead basically took advantage of that when they hit him, popped the top right off of there.
So this is actually different than their failure mode the first time when they fought Tombstone, because that time they actually had a bad batch of material, and that was their cause of failure. This time they made sure that they used 6061 aluminum, so the material was good, but since they had used this part in past matches, they just think that, all that stress got to the part.
Yeah, it just kind of goes to show that even if a robot looks good visually, you need to look a little closer, because some of these parts, they get so much stress and so much, energy put into them that they'll have little stress risers, little cracks, and then Copperhead comes along and rips your head off.
Mm-hmm. So after this fight, the Gigabyte team actually goes and redesigns and manufactures a new spindle or weapon shaft for their next matches, so that they make sure they don't have this problem again. So they're going to use a different material. They're going to add some radii to reduce some stress concentrators. So this is actually really, really impressive, and we'll see if they can get this done, probably in 24, 48 hours is all the time they have.
Good luck.
Now it's time on our show where we ask you, the fans, what your questions are.
I'm Chris.
And I'm Lindsay.
And we're Behind the Bots, the podcast that makes exclusive content for BattleBots builders with their own vlogcasts.
This week we have a question from Jason Lau, and he wants to know, why did you choose the flat wedge over the pyramid wedge that beat Tombstone and Icewave? Was it due to weight, or perhaps not having the undercutting blade configured for that setup?
Great question. I think this week, instead of throwing it to Technical T-Rex, we're going to throw it to Victor Soto from RotatoR to answer the question himself.
So the V-Plow was a really cool design. And back in the original design of RotatoR, we had a single motor driving the blade. And that gave us enough weight budget to have about a 30 to 35 pound blade, which is a decent size. And that's what we used against Icewave. Between that season and then the following season, when we fought Tombstone, we actually changed the internals of the robot to have dual motors driving the weapons now. And so that gave us less weight for the blade when we used the V-Plow, because that V-Plow is very heavy. It's 1/2-inch tie with a lot of internal bracing welded on. So for the Tombstone fight, our bar was really only about a little less than 25 pounds, which isn't great. And as you all saw, it just shattered into a million pieces because it was too hard. So in addition to that, we also got a lot of damage internally that you couldn't really see in the show, where if you look at these photos, we were able to find a lot of the pieces that we lost in the match scattered across the arena, and we tried to collect them all because we wanted to get it all rewelded and patched up so that we can fight other horizontals in the future potentially. So we took this over to the Lincoln Electric guys, and we just decided, well, brackets are broken. The frame that supports the V-Plow is all bent. Tombstone was hitting so hard that it actually bent all this bracing in the inside. But let's just cut the plow in half, because the angle had actually changed from all the impacts. It got flattened. So none of the bolt holes on the top lined up with the frame anymore. So let's say, okay, we said let's cut it in half, basically plast it on the frame again, and use the frame as a jig to re-weld everything during the event. But what was funny, it was the Lincoln Electric guys couldn't cut the plow in half because it was such thick material that by the time they were a few inches down, everything above it started remelting on itself, and they couldn't really just get a clean cut. So it took a lot of effort, but my teammates ended up using a hand grinder with a cutting disc to cut that half-inch tie all the way across top to bottom so we can rejig it. We got it re-welded and we got it put back together, but we ended up not really having to use it again in the rest of that competition because we never fought another horizontal spinner. So for the 2020 season, I actually wanted to make something that was a little bit stronger and more lightweight so that we had more allowance for a larger blade. So for the Valkyrie fight, as you saw, we have this new flat plow. It reuses the same exact wheel guards from previous years because we don't want to waste it. We try to reuse as much as we can, so because everything's really expensive with these robots. So we were trying to match the shapes again, and we just went with a flat shape. And I said, this should be a lot easier to replace if it gets damaged because you just swap out that flat plate and you put another one. And it still had a lot of internal bracing. Due to time constraints, we only had one set of those. And instead of just being all butt welded together, just basically two parts joined and then welded, everything was actually interlocked and then welded. But Valkyrie hit a lot harder than I expected, and they just didn't stop the entire match. They were so durable with their weapon. I give a lot of credit to them. They just kept chipping away at the plow, and some flaws that I, in hindsight, that I see is there's a lot of exposed edges on the sides. It just kept hitting those edges over and over again. And ended up breaking all the welds again. Even though everything was interlocked, everything just flew apart. All the welds broke, all the bolts sheared off, and it took apart some of the wheel guards with it because everything's all bolted together from the outside to make it like a strong shell. So it's not just armor bolted to frame, it's armor bolted to frame and to wheel guards to make a big, strong shell. Unfortunately, it was a lot of damage, so we weren't really able to fix it during this competition. So we just put it in our robot graveyard in the side of our pit. But it was an excellent match, and if that's how I lost, then I think I'm really proud of that match because we went down fighting.
Now it's time for tonight's Thing of the Week. Honorary Degree of the Week?
I didn't put that one in. Did you put it in? Wait, what?
In this week's episode of BattleBots, we saw Jenny Taft wow us with not one, but two technical segments. She explained the physics behind Sawblaze's hammer saw, and she went into detail on what caused all those sparks between Valkyrie and RotatoR. I hereby deem her Technical Jenny, and present her with this officially technical diploma. Congratulations, Technical Jenny.
Technical Jenny, teaching us stuff we didn't know.
Well, that's our show. I have no idea what just happened. Go to the montage. stop me at some point?
We tried.
Tried, but you were sneezing
You
loud.
couldn't hear because you were yelling so much. Okay.
Okay, there's that. That's that.
Or
The student uppercut becomes the master and banishes Sawblaze to the gates of hell in a fiery display.
Hell yeah, brother!
Yeah, brother!
When we were getting the robot ready, I had left the 50-pound blade by accident, and with this configuration, because the plow is so heavy, I couldn't use the 50-pound blade. I had to go down to the 30-pound blade, so we were almost 20 pounds overweight, and we were like, oh, what's going on? And we realized, oh, we just forgot to swap the blade. Okay, no problem.